Hello, testing, testing. The mic audio good? Okay, I think the mic isn't peaking and that's a good thing. Hello, hello. Bam. Alright, hello, good morning, or afternoon, evening, wherever you are. We're doing some basic leak coding today with Typescript. Okay, so last time we did, what did we do? TwoSum, best time to buy and sell stock, contains duplicate, and we learned some valuable lessons last time, like the dot for each loop in Typescript. Apparently you can return stuff from there, which really threw me off. Hopefully that won't happen again today. Okay, so next problem is product of array except self. Given an integer array nums, return an array answer such that answer I... Oh, hi Deepak, hello. I just realized I can't read chat very well because the screen is blocking. Hi Deepak, how you doing? Such that answer I is equal to the product of all the elements of nums except nums I. The product of any prefix or suffix of nums is guaranteed to fit in a 32-bit integer. You must write an algorithm that runs O of n time and without using the division operation. Okay, I'm gonna be honest, I read this problem before the stream started. I was like, wait, how do you do this again? I kind of panicked, but then I read the hint and it was like, what did it say? Think of how you can efficiently utilize prefix and suffix products to calculate the product of all elements except self for each index. Can you pre-compute the prefix and suffix products in linear time to avoid redundant calculations? Oh, hi Pembu, hello. How are you doing? Oh yeah, Pembu, I kept forgetting to ask you. I'm doing a We Compete to Make the Dumbest Tab kind of stream. Do you want to join or judge it sometime? I think I wanted to tell you this last time too, but I totally forgot. Okay. Yeah, they basically just told us the answer in the hint, didn't they? But the question is how to implement this, so we're going to go from left to right and compute the prefix product up to each index, and then go from end to start and calculate the product, like the suffix product from end all the way up, but excluding the current index. We always want to exclude the current index. Deepak says, can you leave the link for the problem list? Oh, yeah. This is the one I'm using. If you Google blind 75 leak code questions, you know what? Maybe I can... Whoop. Oh wait, me saying Google just activated my phones. I use a Google Pixel. Yeah, let me see if I can leave this in the link. I'll have to open up my studio. I don't have that open right now. New window. Live control room. Oh, okay. There you go. Okay. Pemu says, DM me the details. Is it the same like LeetCode 75? Yeah, LeetCode 75, but in TypeScript. I want to try it in TypeScript because I suck at TypeScript. And my current job uses it sometimes. Yeah. I was hired as a backend engineer mostly, but they've been pretty nice in allowing me to do front-end stuff which uses TypeScript, which is not my forte, so I'm practicing like this. Okay, so first things first, we need to go from start to end and then calculate all the prefix products, excluding the current index. Okay, so we need a let prefix product is equal to 1, and then we need to initialize a array. Oh no, how do you instantiate an array again? const prefix I don't know, list is equal to oh no. I would even instantiate an array with a constant, like a set length already. Typescript, how to instantiate array with set length. Maybe this is worth writing down too. New array 5. Oh. I feel like I should have known that. You know what? Let me write this down. Next to the dot for each cannot return stuff note. So create new array. Unlike Java, you don't need to specify a length. Is it? Oh. Wait, how do you specify without array? Without a length, just array? Okay. Create array. So you just do new array 5. Okay. Constant prefix list is equal to new array 5. Is it 5 or whatever the length of the number is? Nums.length. Instantiate an empty array is fine. Wait, really, is it? What if we want to access indices? What happens if you try to access indices in an empty array instantiated like array? Trying to access any indices will result in undefined. Oh. Sparse array, okay, dense. What happens if you try to insert an element into like that? Push, unshift. Oh, right, you can do like stuff like push. Add an element to an array. I see. It just returns undefined. Oh. What's the most popular way to initialize an empty array? Oh, that's it. Okay. So I really could have just done like that. Sick. So then we iterate through nums dot for each. Every num so then we want to exclude the current number, right? We want to exclude, we only want the prefix product up to the current point. So in prefix list, oh wait, we need the index too. So the index is here. The current index of the prefix list is equal to just the current prefix product. Yeah, and then you update the prefix product after you iterate through the number. So prefix product times equals the current number. Okay, it's time for a sanity check. Are we even doing the right thing? Console.log the prefix list. And then we'll just return a bogus value. Return empty array. Run. You can also just assign to the index directly. Oh. Cannot find name prefix. Dang it, I can't type. Yeah, accessing elements that don't exist doesn't result in an error, just returns undefined. Ooh, okay. Oh, hey, get that. So the input is 1, 1, 2, 6. That looks right to me. Yeah. Okay. That's cool. So now we need to find the suffix product. So we're good on the prefix product. Let suffix product equal to 1 constant suffix list is equal to that. I see, you can also just assign to the index directly. Wait, that's so convenient. It's way more flexible than Java, where you have to guarantee that your list is, you know, the correct length. And it complains a lot. This is like so flexible. Okay. How do you go backwards in dot for each? ChatGPT, help me. How to go backwards in dot for each loop? Or is it easier to do with a index, like regular for loop? Using a reverse index. Yeah, I feel like JavaScript is spoiled in a lot of ways. Yeah, it's so convenient. No need to worry about array length. Wait, what's even the array, new array with the length used for? That seems pretty redundant then. Okay, so it's saying to reverse the list first. That doesn't seem very efficient. Okay, yeah, it's recommending a regular for loop. Okay, there's no... I'm gonna do a regular for loop then. So we're gonna do a for let num is equal to let I is equal to nums dot length minus 1. Oh my goodness, I cannot type. Well, I is greater than or equal to 0, I minus minus. Can I first make sure I'm even doing a for loop correctly? Three, two, 1, 0. Okay. You know why I'm still so... I think I realized recently why I'm still so horrible with TypeScript, even though I've written so much TypeScript at work. I use AI a lot at work. Like, we're literally trained to write code with AI. Yeah. Our CEO bought subscriptions to Cursor and Codex, and he's super encouraging to us to use it. But at the same time, we're more productive, but I feel like I don't internalize anything that I write, especially for TypeScript, which I don't know at all in the beginning. What am I doing here? Oh, yeah. The suffix product list. Wait, no. We need to update our suffix list first at I equal to the current suffix product, and then we update our suffix product. Times equal the current number. Oh wait, num isn't defined. Nums I. Okay. Okay, sanity check again. Let's print out the suffix list. We don't need this console I log anymore. Bamboo says you output more in the short term, but I suspect long-term maintainability and learning suffers. Yeah. I really do feel like I learn less typing with AI. Like, I can read the code alright, but... Okay, this looks plain wrong. Oh wait, no. Wait, is it? Numbers are for This looks wrong. Oh. Suffix product? Why are the numbers so huge? The suffix list. It should be like 412. Oh, no, we're going backwards. This is right. Wait, am I going crazy? The suffix up to 4 is 1. Yeah, this is right. Suffix up to 3 is 4. Yeah. 2 is 3 times 4, 12. 20. Oh, no, this is right. Yeah, okay. I'm on the right track. You output more in the short term, but I suspect long-term maintainability and learning suffers. Yeah. The maintainability part is like I don't know. I feel like we're okay with maintainability right now because our front end senior software engineer doesn't use AI. She does it the old school way. So all of our AI code has to go through her. And she really tries to make it like clean and easy to maintain. Whenever I give her a PR, she gives me lots of comments about cleanliness of code, abstraction, stuff that AI doesn't take care of. So I have to go in and do it myself, and I learn from it. But I really do feel like, it makes me a whole lot more productive. Like I can read TypeScript. I can't write TypeScript very well. Like some of the stuff it allows me to do is like I would not have been able to do without like Claude or ChatGPT, like designing a UI in Bamboo says that sounds like that will be me in her role. Hey, you're that type of person too? Do you not code with AI? Or are you like one of those people who've coded enough, like long enough time in AI that you basically have things down already? Okay, suffix looks is good. So now we just have to iterate through each index and then take the prefix, multiply by the suffix, put it into a list, and return it. Yeah, all right. So let constant the result is equal to just an empty list. Oh my gosh, that's so convenient. You don't have to specify indices or whatever. I don't code with AI, no, I haven't even touched ChatGPT. Oh, wait, I really wish that my company doesn't prioritize outputs so much sometimes. Like, we're literally trained to code with AI, but I feel like I don't learn anything sometimes, except just like the overarching concepts. Okay, for loop, I can just copy this thing. Like, look how unfamiliar I am still with TypeScript. If I was typing with TypeScript the entire time myself, I would be so much faster now. Less than or equal to nums.length I plus. Oh yeah, you want to know something funny? Like how much our people rely on AI and why I started to use it so much at work too. Like my boss has complained, or not complained, like just friendly advice that he thinks that my output in the past was like too slow. And then I like listened to what our senior engineers in the back end and some of the other junior engineers had to say, and they were like, I basically haven't written code in months. I've been using everything with like Cursor and Claude, and I basically just opened up two cursor windows and then multitask like that. I haven't written code in months. I was like, oh shoot, I have to. Maybe that's what I have to do too. And then now I do that too. So then, yeah. Boss has not complained about output in months now, or like ever since he said that the first time. But boy, am I not learning anything. Well, I still learned the like rough concepts of React because you can't get away with that. But the actual like, if you ask me to type TypeScript myself, it's like hard. I can read TypeScript very well now because I have to review the AI code, make sure it actually makes sense. But typing it myself is like a foreign language still. Yeah. Okay. Result I is equal to prefix product prefix list I times the suffix list I, and then that should be it, right? And then we just return result. Runtime error. Oh, great. Why? What is wrong with this? Oh wait, less than. How was I even supposed to read this error message? There is no valid value for the expected return type integer. There is no valid value for the expected return type. Oh. Alright, I guess that makes sense. Hey, let's go. Submit that boy. The console.logs will probably add to the runtime. Yeah. 7%. Submit. Hello? Oh, 11%. Okay. I suspect the fastest way of doing it is probably just iterating through it once, right? And then, wait, would that be faster? It's still, well, I'm doing 3 passes. This one will be 2 passes. Maybe the fastest way would be to iterate through it once and then times everything together, and then for each index and the result, you take the end product and divide the current element by it. But then it explicitly says that without using the division operation, so... Alright, are people actually doing the division operation? Okay, let solutions array equals new array nums.length fill. Okay. Left product. That's basically what I'm doing. One. Oh wait, but they're filling up the solutions array while they're doing the right product. Oh. Oh, that's smart. So they reduce one iteration like this. Yeah, wait, you don't have to store the suffix product because you're just going to use it immediately. That's kind of smart. You know what? I'm going to try that. Okay. So the current suffix product is that. We don't need a suffix list anymore. We can just do result that the result list immediately. So instead of the suffix list, we update the result instead. I is equal to the prefix list I times the suffix product, and then you update the suffix product. And then after this, you return the result. I feel like that's what you do. Nice. That's pretty smart. Alright, we're higher up. What are the top people doing? Array number. I feel like they're doing what I'm doing. What if I try submitting it again? I feel like LeetCode timer is sometimes very finicky. 20%, okay. Oh well, I got it. Let me just record this problem down actually. I couldn't figure out how to do it at first without a hint. Pambu says for each is slower than a real for loop. Oh yeah, you told me that last time. Is it actually much faster if we do like... You know what? For funsies, I'm going to try a real for loop. Let I is equal to 0. I is less than nums dot length I plus plus. Prefix list index is equal to prefix prod, that's okay. Wait, no, that's not okay. I prefix prod times equal nums I. Wait, does that make sense? 0 to the end, prefix list I is equal to prefix product. Prefix product times equals nums I. Yeah, okay. Come on. Okay. Why? Let me try again. Do they start throttling how much resources you can use if you submit too many times in a row? Who knows? Okay, I don't care anymore. Next problem. Maximum subarray. Okay, given an integer array nums, find the subarray with the largest sum and return its sum. Given an integer array nums, find the subarray with the largest sum and return its sum. What in the world? How? Okay. Maybe some examples would help. -2, 1. This is the list. The output is 6. The subarray 4, -1, 2, 1 has the largest sum of 6. Wait, hold on. I might have a vague idea of how to do this. I may have seen something similar before. Or I may have just seen this problem in the past. You could do prefix sums, right? The way to tell, like, if you want to take this, if you want to find the sum of this particular subarray, you would take the prefix sum from here wait, it's not prefix sums. You would take the sum of 4 to the end minus -5 to the end, basically. So it's suffix sums. Alright, so you would try to find Wait, no, you can do prefix sums. 1 to the start minus -3 to the start. Okay, but how does that help me? MG John says, oh, I really don't like LeetCode, just gives me PST to uni. Wait, you LeetCode a lot in uni? I don't recall doing that much in uni. It's mostly after college when I'm searching for jobs I did LeetCode. Wait, hold on. I'm struggling to remember how to do this problem. I remember it has something to do with prefix sums. But what do I do with the prefix sums? Any hints? Really, no hints. Okay, guess I'm alone on this one. Subarray with the largest sum. Okay, maybe I can just... Maybe it's helpful to think of what the brute force solution would be. So, for every index, you would do a j, and then iterate from the current I to the end, and then record your max. Increment I, do the same. So that'll be O of n squared time. Okay. Why do I remember that there's a prefix sum way of doing this? You just iterate once through. 2, 1. MG John says, oh no, it was very similar to such question in C++, so ever since then I can't look at these sort of questions. Oh wait, I know what you're talking about. Yeah, in the intro to CS classes they had like very Lee Cody questions. But they were like, actually yeah, they were hard too. Wait, how do I do this as prefix sums? There should be a way to do this in like O of n time or something. So I have negative, so I go from start to end, -2, okay, -2 and then 1. You know what? I'm gonna draw this out. I'm gonna try to maybe spend 5 minutes trying to figure this out on my own before I peek at the solutions. Okay. Prefix sums. There should be a way to do this in O of n time. I know the n squared time way. Okay, so prefix sums, this would be -2. This would be -1. -3, -4. +4 is 0, -1. Am I doing this math right? 1, 2. 2 minus 5 is -3. +4 is 1. Okay, I have all these prefix sums. What do I do with it? So how do I know that 4, -1, 2, and 1 are the biggest stuff? So what I could have done is take 2 and then minus -4, which is 6. Huh. So do I just hug the minimum and then find the thing that's bigger than me after me? The biggest number after me, the minimum. Okay, that's my guess on how to do it right now. I feel like that makes sense actually. That's kind of similar to the when to buy and sell stock problem. So I can do this in 2 passes then. First, find the prefix sums, and then find what would give me the most profit, right? Because the sum of any subarray is just the prefix sums of the end minus the prefix sums of one, like the beginning index. Yeah, okay, that's my guess on how to do it. I'm going to double check with solutions. This guy claims he has a solution. Sure, I'll read it in Python. Result is this. Oh my goodness, this is so simple, what the heck? For n in nums, if total is less than 0, total is equal to 0. What does that mean? Kadane's algorithm, MG John. Total plus equals n. Res is equal to max res total. What is going on here? I have to watch this video to understand. Is there something I can read for this? This is not problem solving, this is just knowing what algo to use when. Kadane's algorithm. Kadane's algorithm. Dynamic programming. Really? We have to use dynamic programming for this. Naive approach. N square time, yeah, that was my initial one. O of n time and O1 space. The idea is to traverse over the array left to right and for each element, find the maximum sum among all subarrays ending at that element. The result will be the maximum of all these values. Oh my goodness. Below is the implementation of the above algorithm. Why does it look so complicated? Oh, this looks kind of better. Result is equal to array 0. Okay, so they're taking the first element. Max ending is equal to array 0. Is max ending like the prefix sum? It's very basic in its core. For every I in range, I in length r, find the maximum sum ending at index I by either extending the maximum sum subarray ending at index I minus 0, or by starting a new subarray from index I. Max ending is equal to max ending plus the current one, or just the current one. Find the maximum sum ending at index I by either extending the current maximum. Oh, so you take your best solution so far and then add where you're at currently, or you start a new one from the current one. Oh shoot, okay. MG John says, yeah, I don't get the one you're looking at. Wait, is this not Kadane's algorithm? Update res if maximum subarray sum ending at index I is greater than res. Result is equal to max the current result, or the best max ending at the current index. Okay, I guess it kind of makes sense to me, but I wouldn't be able to come up with this on my own. Is this not the Kadane's algorithm you're talking about? Does someone have... This guy claims to have simple solution. 7 simple solutions with explanation. Abhishek. Well, this one has 3K upvotes. Maybe it's worth taking a look. Brute force DP plus Kadane, divide and conquer. Brute force. Okay, yeah, we're not looking at that. Recursive. No thanks for now. Dynamic programming. Oh boy. They're doing it in C++ too. With tabulation. Okay. Kadane's algorithm. DPI only depended on DPI minus 1, so do we really need to maintain the whole DP array of n elements? Okay, this is in Python. Current max till now, 0, comma, negative infinity. Sure. For every C in numbers, the current max is equal to the max of, like, just starting the number currently, or taking my current best solution and adding my current number to it. Max till now is equal to max, the current max, or the max till now. Okay, that makes sense. And then return the max till now. That kind of makes sense to me. Like, I understand what the code is doing, but how did you come up with it? MD John says, it is. I was commenting on the first solution, which isn't optimal, but I couldn't tell you one experience I had where people cared about the optimal. I see. Okay. This does seem like really clean, and I understand what the code is doing, but it's like, oh my goodness, this code is so long. Okay, let's cover up Kadane's solution and try to implement it then. So what we need to do is the current sum. Is the current sum? current max till now. I feel like it makes more sense to call it something like the max you can achieve at the current index. Wait, yeah, current max is a good name then. Okay, let current max at the current point is equal to 0. And then best solution, best max, best solution equal to 0. Okay. MG John says that logic seems like it would fail. Well, yeah. I understand what the code is doing, but why it works is like, interesting. Okay. Time to make the for loop, I guess, for let I is equal to 0, while I is less than nums dot length I plus plus. Okay, so at each, let's get the current element. Const num is equal to nums I. Okay, so the current best solution that you can get at your current index is equal to the max of your current max, like the previous one you got, plus your current number, or you start fresh with your current number. And then your best solution is equal to the max of your previous best solution and the best you can do at the current spot. And then you just return your best solution. This should be negative infinity, right? Is there a way to do negative infinity? Is that how you do negative infinity in TypeScript? TypeScript negative infinity. Oh yeah, you can just do negative infinity. Very nice. TypeScript min-max. Yeah, that's it. Oh, you have to do math.min, math.max. Maybe I should write this down too. Math.min max. Pambu says, yeah, that's it. Oh, thanks, Pambu. So, do I really have to do math.max and then math.max again? I feel like Java is kind of similar in that too. Okay, let's see how many compilation errors I have. Wow, it just worked, okay. Wow, look at that, just one pass. Yeah, this is the type of solution that's like, I understand what the code is doing. Why does it work? Cadane's algorithm. Alright. Maybe I should write this problem down for review too. I want to see the solutions again. Is there like a more intuitive way of doing this, even though the solution might not be as fast? Dynamic programming. Recursive. At each index I, we can pick that element or not pick it. If we pick the current element, then all future element must also be picked, since our array needs to be continuous. Pambu says you can do const max equals math somewhere before to use just a bare max, but nobody really does that. Oh, okay. If we had any picked elements until now, we can either end further recursion at any time. Maybe I should just read the code. Ooh, this recursion seems really simple. Solve I, must pick. If I is greater than or equal to length of nums, return 0. If must pick, else negative infinity. Wait, what the heck does that mean? We will use must pick to denote whether we must compulsorily pick current element. If we pick the current element, then all future element must also be picked, since our array needs to be contiguous. If we had picked any elements till now, we can either end further recursion at any time by returning sum form till now, or we can choose current element and recurse further. I actually have no idea what it's talking about. Maybe I'll just stop with Cadane's algorithm. Alright, I feel like my prefix sum solution would have worked too, by the way. You figure out the prefix sums in one pass, and then you do a similar to find the best time to buy and sell stock. So 2 passes. Yeah. Actually, for funsies, I'm gonna try. Can I try this solution that I just proposed? I feel like it would work. So prefix sums, let const prefix sums is equal to an array with no initialization stuff. Anna the glitch bustler leader. Wait, what? Anna the glitch buster leader. Whoa, why are you called that? Hi Anna. Hello. What's up? Why are you called the glitch buster leader? That's such a cool name. Okay, prefix sums. Let current sum is equal to 0. So then nums dot for each. We will have the current num and the index. Anna says, I joined a Discord. You're the leader of the Glitch Busters? Is there a Discord like that? The Glitch Busters? What does busting glitches even mean? Patching bugs? So you're like... Are you like the CEO of a startup or something? Whose job is to patch or lead the way in patching bugs? Prefix sums at the current index is equal to current sum I feel like that works. We might have to increment sum here though. Sum plus equals the current num, and the prefix sums index is equal to sum. Yeah. Console.log prefix sums function whose declared type is neither undefined, void, nor any must return a value. Oh. Let's return a bogus value called -1 or something. Anna says, I'm Padley. Padley? What does Padley mean? This woman is very interesting. First she's a glitch buster leader. Now what is a Padley? Like a paladin maybe? Paladin? Prefix sums. Also, why is my prefix sum so complicated? 2, -1, -4, 0. Yeah, this looks right. And then what we need to do is iterate through the array, hug the minimum, and then find the best time max profit we can make, right? Okay. How to do this? Let min is equal to negative, wait, no, infinity okay, and then for let I is equal to 0, I is less than nums dot length I plus plus let max profit is equal to 0 or like negative infinity. Okay, so the current max profit is equal to the math dot max of your current max profit and your current number, so nums I minus your current min. And then you update your current min. Min is equal to math.min, your current min, and your current number, nums I. Oh boy, if this doesn't work, it's gonna be so hard to debug. Actually, it's not hard, it'll just be a hassle. And then you return your max profit. Runtime error. Plus is not valid value for the expected return type integer. Oh, negative infinity is not valid value for the expected return type integer. Should I be starting with num0 instead? And then do nums1? Dang it, I might have to print out some stuff. Console.log. Let's print out looking at the current number. Nums I. Console.log current min is equal to min max profit max console.log max profit Okay, let's run this. What does this even mean? Am I biting up too much right now? Okay, let's start really simple. Max profit, let's just do like 0 or something. And then let's just focus on hugging the minimum right now. Min is equal to math.min, the current min, and the current number. console.log the current minimum, submit. Okay, min is -2. -2. Yeah, okay, this makes sense. -3 all the way to -5. Okay, we're getting somewhere. And then our max profit our current profit is equal to the current num minus the current minimum. Yeah, and then the max profit is equal to math.max, your current max profit, and your current profit at this specific index. And this should probably go towards the end, because you can't, buy and sell on the same day. No, it didn't work. Output 9, expected 6. How did I get 9? Output 0. Dang. So I just have 1 here. Oh wait, hold on. You can buy and sell on the same day. No. So I literally just don't enter into this for loop then. Oof. Okay. And then I'm subtracting 1 and 1, which is not good. Maybe this buy and sell stock method isn't the best way to go about this. How do I even take care of the fact that you can subtract like a 0? That if my prefix list looks like this, I could literally just take 1. I could maybe add like a 0 at the beginning. Oh boy. Like that, and then prefix sums dot push the sum zero, 1. Okay. I'm starting to think this is a really bad idea, but I feel like I can force this to work somehow. Maybe I'll spend like 5 more minutes on it, and if I can't do it, I'll just say, okay, this isn't the best solution. So the min is 1. It thinks the min is 1. What? Why? Min is num 0. Oh, prefix sum 0. Hi, subscribers on YouTube. Oh, thank you for subscribing. I appreciate it. I should take the prefix sum 0 instead. Okay, this is finally right. What about these? Min is 0. My output is 9, expected 6. How in the world did I even get 9? That don't make any sense. Okay, when in doubt, print stuff out. So let's print out what number we're even currently looking at too. Current profit. Hold on, I just realized we're not even looking at the right array. We're supposed to be subtracting from our prefix sums. Current profit is equal to prefix sums I minus the min. Max profit is equal to math.max, the current max profit and current profit. Min is equal to math.min, min, and then prefix sums min. Oh my goodness. Okay, this is working now. Oh boy. Nice. And this is not working anymore. 0. The current min is 0. Okay. So you would take 1. Why are you not taking 1? Console.log current prefix is prefix sums and then I. Current prefix is 0. Oh, we never get to 1. Why do we never look at 1? Oh, because we're taking nums.length. Oh my goodness. Prefix sums.length. Okay, we're getting somewhere. Oh, finally. It worked. See, guys? Prefix sums does work. It just cost me my sanity. Oh, God. -1. Apparently my output is 0. Okay, so this should be like negative infinity. Use the test case. Hello, use the test case. Run the test case. We're so close. 195 out of 210. Zero, -1. Oh wait, max profit? Min? No, min can't be... Min can't be 0 at all. Output is 1. What in the world? My output is 1. Can I just do like infinity? Please work. Holy, I don't want to do this anymore. Oh, finally! I don't even care. That's so slow. See, guys. See, guys. Prefix sums does work. It just cost me my mental health. And it's slow as heck. Okay, fantastic. Oh, I feel like I proved a really horrible point. It's still O of n time though. We did do 2 passes. Yeah. Oh, this is horrible. Okay, so what did we learn today? We learned that to create an array, yeah, we learned that arrays are really convenient. You don't need to instantiate size. You don't need to do like new arrays, 5 length. you can just do empty array, and then it automatically takes care of the indices for you. Auto takes care of indices. We also learned how to do min-max. You have to explicitly write mat.min and mat.max. We also learned that don't do prefix sums for max subarray. Use Kadane's algorithm. Holy. I'm definitely writing this problem down for review. Okay, we did some problems today. We learned some stuff, and that's all that matters. If I didn't learn anything today, it would have been for nothing. But we did learn something today. Okay, I think I'm done today. Oh wait, I have something I want to plug. Where did my Krita window go? Oh, here. How do I even get... Okay, give me 1 second while I share my Krita window. Window capture of Krita. Oh, interesting. Why can you not see my window at all? Yep, looks like you cannot see anything. Well, that's a bummer. What if I use a existing window on OBS? Window capture, add existing. Oh, there we go. Finally. Okay. I have some exciting news on hold on, let me make sure I get the day right. Okay, on July 5th, 10 a.m. PST time, we're going to be doing another We Compete to See Who Can Make the Dumbest App episode. This time we have Snowy, Summoner Eye, and Silo. Silo's not here yet because he joined a bit later. But yeah, Snowy works at some of the top gaming companies in the world. He has worked with them. I don't know much about Summoner Eye. Silo is really good at AI coding. Yeah. So this is going to be on July 5th, about 3 weeks from now. Very exciting. Oh, and also, been recent, episode 1 of We Compete to Make the Dumbest App is going to be out soon. I'm still waiting on some people to send me their footages, but the full-length edited video will be out soon. Yeah. We streamed this live last Saturday. It was pretty fun. But yeah, Pembu, I can send you details at the end if you want to join as either a coder or a judge. The premise is basically we make dumb apps, we pitch them Shark Tank style to a panel of judges, dumbest app wins. The app can be like anything from a Python function to a full-blown website, anything you want. As long as it's dumb, it's good to go. No need to make it super complicated. But yeah, this full-length edited video is going to be out soon. It's not going to be just like a edited version of what we streamed. It's also going to contain like behind the scenes of us making the app. And yeah, we're going to break down what tools we used, what inspired us to make the app, where we got our ideas from, things like that. Yeah, and then episode 2 of We Compete to Make the Dumbest App will be on July 5th. It's going to be exciting. Spoiler alert, my next topic is going to be Pokemon related. At least that's what I'm working with right now. Pembu says, yeah, send me a DM. I was lurking for that first stream, so I saw what went down. Yeah, totally, I will. All right, that's it from me, guys. I'll see you guys next time. Probably next week. All right, bye. Have a good day.